Here we have a negative feedback system. This is our original amplifier, having an amplification factor of A. Normally we just take Xi and multiply by A to get X out. But with negative feedback, what we do is we take a little bit of the output, multiply it by beta, making this signal we called XF, which is the feedback signal, and we subtract that from the input signal XS, and that becomes Xi. And so this is a situation where what we actually get at the output is used with this factor right here to make the difference between XS and XF essentially 0. Let's see how that works. So X out is A Xi, as you see. A times Xi is X out. Xi right here is XS minus XF. See, plus, minus. XF is beta times X out. So XF is beta times X out. X out, therefore, is A, that's this A, times Xi. This is the Xi, which is XS minus XF here, but XF is beta X out. So writing it this way, you have a function that's X out is a function of XS and X out, and you can therefore solve for X out. When you do that, you get X out equals A over 1 plus beta A times XS. And so the gain dropped by a factor of 1 over 1 plus beta A. See the 1 plus beta A in the denominator. This thing in the parentheses right here is the gain after feedback. We call that A sub f. Let's look at what happens to A sub f as A goes to infinity. If we take the limit of this as A goes to infinity, the A's become very large, and this extra 1 here hardly does a thing, and so this tends toward 1 over beta. So this limit is 1 over beta. And notice that that only depends on beta. And beta, if this AF is going to be greater than 1, beta is going to be a small number. That means that beta could be made up in electronic circuits only of resistors, which are the most linear elements that we have in all our arsenal of electronic components. And they are probably one of the easiest to manufacture and the one of the best components that we can actually make. So the gain, if you have a lot of gain right here to give away, a lot of A, you can get an amplifier with a gain that's determined entirely by resistors here, because resistors turn the signal down. That means beta is less than 1, like a voltage divider. Okay, let's look at what happens to the Xi. Xi is known as the error signal because it's the difference between our input and this output factored by multiplied by the beta factor. We're trying to drive this value and this value to be the same. This is like a miniature value of your X out, and you're trying to make X out look like a miniature value of XS because you're trying to make these guys go to 0. Let's see how that works mathematically. So if you notice, Xi here is X out divided by A. So Xi equals X out, that's an O right there, divided by A. Well, X out is A over 1 plus beta A times XS, using this formula up here. And, of course, we still have the 1 over A right here. So these A's cancel, and you end up with XS over 1 plus beta A. Notice that the signal right here, the error signal, looks just like that guy right there, only he's divided by 1 plus beta A. In other words, he's smaller by a factor of 1 over 1 plus beta A. Take the limit as A goes to infinity of this quantity right here, you will get 0 because A gets really big, and so the denominator gets large and you get 0. That means that this error signal goes to 0 as you have a larger and larger gain here.